Hello guys, welcome to the channel. I hope you all are fine and doing great. Today we are going to discuss this GFG problem of the day, that is reverse alternate node in linked list. After so long I am recording a lecture, and from a fourth year student to a software engineer, now I don't find time, but I will try to consistently record the video and upload them on my YouTube. So please subscribe the channel and like the video, because from now I will gonna to upload lead code contest solution as well. By the way, I just became guardian as well. Okay, so let's move on to the problem. So quick intro about me. I am an expert on code forces, 4-star on CodeChef, soon to 5-star, hope so. So that's about me. So now just starting the problem solution. I just tell you this thing because after so long I am making a video. Okay guys, so here we are given a linked list. Like basically what I need to do here, I am given a linked list. Okay, then suppose this is A. Okay, I just need to worry about alternate nodes at from starting position is equal to 2. So A, suppose this node have any value D, and this is C. So what I need to make these all node 1 2 3 4. So how my linked list should be look like? 1 2 3 4 means I need to remove all these nodes first of all, then need to make a other linked list so that it will be like this: B and A, and this point to this. Okay, are you getting my point? 1 2 3 4 in manner, then this D C B A in reverse order like this. And you can see, for example, here. Okay, just let me quickly write the example. I am given 10 4 9 1 3 5 9 4. Then after the center node are 4, erase this, then 1, then 3, then 9. No, just a minute. I just 10 4 9 1 3 5 9 4 3 4 9 4. Yes. So center node are 4, then 1, then 5, and then 4. Okay, these two are the nodes. This 4, this 1, this 5, and this 4. Okay, so now these all in same order, these all in reverse order. So like first of all this 4 will come, then this 5, then this 1, then this 4, this 4. So you can see 10 9 3 9 10 9 3 9 4 5 1 4 4 5 1 4 is my linked list. So how to do it? Very simple guys. What I need to make, I need to maintain, I will gonna to give you ON approach without any extra space. Okay, that's the best thing about my code. I'm not gonna to use any vector arrays or reverse functionality, just completely optimization that will gonna help you to crack interviews. Okay, so how? Like now, see here, if you closely give this particular linked list a look, these all are in particular manner. Which manner? First node, then third, then fifth, then seventh. Or basically what I can do, head node, next node is head, next to next, then next node is next to next, next to next, like this. Okay, you are getting the point, like what I want to say. Now this particular linked list in a particular manner, this particular linked list in a particular manner. Okay, so if instead of this I say I am maintaining a linked list A B CD. This is very easy task, very easy task to maintain a two particular link list 1 3 4 5. Like suppose if I am given this particular nodes, I need to find out two alternate order linked list. Like first is 1, then 3, then 5, then 7. Other is 2, then 4, then 6 8. Then one way of doing this, maintain this, reverse this. So after reversing it will become 8 6 4 8 4 2. Then add this, like, so that this will become your answer. But I'm gonna to tell you this is very like brute force type solution, not brute force, but I'm gonna to tell you over optimized solution. Okay, so how to maintain this? If you carefully give it a look, suppose I am here, suppose I am at this particular node 3 node. Okay, I am at node 3. So what I am gonna to tell you, this is English is all about examples. First 2, this is A, this is B, this is that. So before this 3, suppose if my two linked lists are like this, and this B pointed to A, B point to A. Now I am at 3, so after 3 I have C, and after C I have 4 node. Okay, so after C I know 3 will gonna to add in this linked list. I can simply add it. I can simply add it, and what I know, I am at 3, so linked list will be like this. Okay, so after 3 I know, after 3 I have two nodes C and 4. So this C will be gonna to add in this particular linked list, this 4 will be gonna add in this particular linked list. So adding this 4 in this list is very simple. What I can simply do, what I can simply do, I can take a variable temp and put this C node in this temp variable, temp point to C variable. Now now I can erase C node easily. I can erase C node easily. Okay, so now give this alone. I can erase C node easily. So what I can do now, I already stored C node in other variable, so I can remove this C and I can update this particular linked list. How? 3 next will point to 3 next to next. So instead of C, like 3, the next of 3 is C, next of C is 4. I don't need C, I need 4. So how can I represent 4? I can take access 4 from 3, 3 next to next. So I can just make 3 next to next will be 3 next. Okay, I remove C. So this C is removed from this linked list. Now first linked list updated, now I need to update this. Now how I want to update this? I need to add C in front of this. Okay, it is very simple. What I can do, I can maintain a variable like stride to or current to. I am maintaining a pointer variable. I am maintaining a pointer variable. Now what this pointer variable is stored? The head address of this particular linked list, this second linked list, this is this. So how can I add C in this? Very simple. I can just put temp. C is represented by temp, so I can just put temp next is equal to current to. So what does this mean? This temp will gonna point out to B. Like this node C that is point out by temp, its next pointer will start to this head, this B. So means all the node like B, A and all the further node will be gonna access. So this linked list is updated, second one. Now what I need to do? I need to make this as current to. Why? Because now this is the head of my linked list. Now I am at 4, after 4, suppose I have two more number D and 5. I have D and 5. So now I can easily put D in my temp. So now temp will point to D, temp will point to other variable D. So what I can do, I can easily remove this D uh, from my linked list. Okay, I can remove this D and 4 next to next point to 5. Sorry for pause guy, my internet got break. Okay, so this I can remove this D is point out by its temp variable. Now 4 next to next will gonna to represent 5. So 4 next will be 5. This linked list got updated. Now simply this D temp next will be I can simply do this. So now this node D will be gonna point out to this C. I can update this C to this. Okay, so after completion of the linked list, what I can simply do, this linked list, this first one, these two linked lists, I have this, I have this. Now this last node is represented by a variable C1. Okay, I will maintain this particular node like this 2 3 4 5. After putting 5, I maintain a variable C1 initially here, then after initially here, then after putting 4, my C1 will become this. After adding 5, my C1 became this. So I can say the last node represented by C1 is its starting node represented by C2. So what I need to do, after completion of my linked list traversal, I can simply do C1 and next of C1 represent C2. Okay, there is some internet problem, so don't worry. The next of C1 will gonna point out to C2. Okay, very simple. So now this linked list we will gonna complete. Okay guys, so now look at the code. Initially I take two variable, current one, current two. These are the starting of my sequential linked list. This 1 2 3 1 will be current one, DCBA will be current two. Okay, this T1 is the temp node where I need to store these particular nodes, these C D A B. Okay, each and every node. Now while I have some extra node, like suppose if I am at suppose I am at 5, then after 5 I don't have any node. So after 5 I don't need to move. I don't need to move after 5. Okay, so this is basically what I am doing. And suppose, okay, this particular case will not gonna happen. Okay, so this case should be exist, like my current node should gonna exist, and node after this should be exist. Now my temporary node will be the next node. Now I will gonna update my current next. I will, this is, I am updating my first link list. Okay guys, now if my current next, now what is this? Now suppose I am at 5, then after 5 I don't need to update, but suppose if I update my current to current next, like here, after 1 I need to go to 2, so I will update my C1 is here, I need to update my C1 to this, I need to update my C1 to this. How can I update? I know I am at, suppose I am at 4, my C1 is here, I add 5 already, then I can just put C1 is equal to current one is equal to current one next, so my current one gonna represent this. But at 5 I don't have any number, so I don't need to update my current one. I can update, but I will be gonna to put out at null pointer here. Here this is null pointer. Okay, but I need last node. Why last node? I need to add this to do this particular operation. As well, I need to run a loop again. Loop again to find out my last node. Okay, instead what I can check, if I don't have any last node, means I have completely traversed my linked list. I will not gonna to update my current one. Okay, current one will represent the last node of first linked list. Okay, if there are some node, then I can move, else I'll not. If there is some node exists there. Now if my current two. Now in my second linked list, suppose this is my first node when I am at A, when I don't have anything, when I have only A. So what I need to do, my current one will be empty, my current two will be null pointer. So my current two will point to A, current two, this is not, current two will point to A, and this A2 next will be null pointer. A2 next will be null pointer. Why? Because as well this A2 will point to this. Like what we're gonna do? This A will be point to this two. So it will become a cycle and you will go TLE. So I need to erase this particular loop. So I need to make A last to null pointer. Okay. If okay, this is if second linked list exist. Okay, if this exists, else why I need to do, simply put that particular node in my current to, uh, that single node is my head, and this current to next will be null pointer. Else while if I have something, then the next of that particular node, like C node, will be gonna point to B, and I will update my current to. Now current to will point to C instead of B. Okay, if B and C are my, if this B and C are my, like my current node is B, current node is C, and B is the head of my current to linked list. Okay guys, this is I'm going to tell. Then at last I have current to updated, current one updated, the last node of second linked list will point to first node of second, the last node of first linked list will gonna point out to first node of second linked list. Okay, this is what I gonna to do. So this is very simple approach of this particular problem, just of and solution. Okay, this is accepted code. If I can show you, okay, this is the same accepted code here. Okay guys, so I hope you like the video. Maybe if you have any doubt in understanding, just vote it again, and just try to elaborate like what I am saying. Just take some example, make some examples, and if you have any doubt, you can just comment out. I will try my best to explain you. I will answer your query for sure. Okay guys, please subscribe the channel, like the video, and share it with your friends as well, because after this video I will gonna to upload many more videos like lead code contest, GFG, and many other tutorials as well. Okay guys, so thank you for watching this guys, stay tuned.